For my project, I'm going to be talking about the habitable moons and planets in our solar system. So the first question I came across when doing the research for this project was, what makes a planet habitable? For something to be habitable, it must be able to fit an organism's needs to live in. This doesn't just mean humans, but virtually anything out there. According to the Genetic Science Learning Center, there are 4 ideal criteria that must be met to provide a comfortable living space. The first thing is that they need to be a comfortable distance away from the sun, much like our planet. This means that they're far away enough that they're out of heavy heat in the radiation zone, but not so far away that they're extremely cold. The second thing is that they need to be made of rock. Automatically, this rules out Jupiter, Saturn, Uranus, and other gas planets due to its gas makeup. The third thing is that they need to be big enough to have a molten core. With a core like this, life can receive a source of geothermal energy. It also protects us from radiation. And the last thing is that they need to have a protective atmosphere, to some degree. It's also important to note that these possible life forms in other planets don't have to be intelligent. In fact, most Earth life is already microbial. The second question that I came across was, are these habitable planets in our solar system? According to the few main criteria necessary for a planet to become habitable, technically, yes, and there are a lot. In November 2013, astronomers reported, based on Kepler space mission data, that there would be as many as 40 billion Earth-sized planets orbiting in the habitable zones of sun-like stars and red dwarfs in the Milky Way, 11 billion of which may be orbiting sun-like stars. Considering these 11 billion planets, astronomers have been able to narrow it down to a good 53 or 54 planets that seem to almost perfectly fit our necessary criteria for life. Then came along Abel Mendez, a planetary astrobiologist and professor at the University of Puerto Rico, who stated that there exists a top 13 list for habitable planets. On that list, he specifically said that Jupiter, Neptune, and Mars could be habitable. But Jupiter and Neptune are gas planets, so we're going to ignore Mendez on that. Now, technically, to clarify, Jupiter does have a rocky core, but it is surrounded by so much dense liquid hydrogen that it encompasses 90% of the diameter of Jupiter, so it seems pretty unlikely for life to be found or to inhabit it. But Neptune barely has a solid surface. Since it's also a gas giant, it probably couldn't house life either. So let's backtrack. How are there so many habitable planets? In astronomy and astrobiology, the circumstellar habitable zone, or the Goldilocks zone, is a range of orbits around a star, within which a planetary surface can support liquid water given sufficient atmospheric pressure. Currently, only the Earth resides within this habitable zone, but you can also argue that Mars and Venus lie within it as well. There are many stars within our solar system, though, that make way for many exoplanets that lie within the habitable zone. These planets are our main focus when discussing our top habitable planets. Going back to Mendez, he named 4 planets that seem to catch a lot of astronomers' eyes, being a few Kepler exoplanets. These planets are Kepler 186f, 1229f, 442b, and 62f, which are commonly regarded as possible habitable planets. So what about moons? Good news. Moons can hypothetically be habitable as well, but there are complications. Even though certain moons fit our habitable criteria, there are certain things that just don't work. For instance, moon days tend to be tremendously long. Europa, which is commonly regarded as a possible moon for life, has a day that lasts 3 Earth days. Titan, which could also support life, has a day that lasts 15.9 Earth days. Along with this, moon atmospheres tend to lack greatly, with the exception of Titan. With such a limited atmosphere, chemicals that are necessary for life can escape to space. The last and most important difference is that moons don't have as much of an axis tilt like we do on Earth, so the climate would remain the same throughout the entirety of life there. So even if it's possible to live on certain moons, it wouldn't be very fun for humans. Now, considering all of this, there are moons that are definitely habitable. For starters, Europa, which orbits Jupiter, is thought to possibly be able to support life. It contains water, oxygen, tidal heating, and irradiation. It does, however, have a very thin oxygen atmosphere. Titan is also a hypothetical moon for life, which orbits Saturn. Like Earth, it is shielded from solar wind with a magnetosphere. It also has an atmosphere similar to Earth, but it is thicker. Other moons include Enceladus, Callisto, Ganymede, Io, Triton, Dione, and Charon. Now, even though all of these moons and planets are thought to be able to support life, this doesn't mean that they actually do. They're simply hypothetical, and science on this is fairly new. But, if you were to ask me, aliens could technically exist, so don't lose hope.